You know, I have. Do you remember that I've shown you clone the AI? No, sorry, the robotics company, and they have got like this full like complex hydraulic system, and they're replicating the like.
Is that the one where they're using the muscle fibers?
Yeah,
yeah, I saw that one. That was good. Yeah,
wild.
You put monomic fiber into that, and then we're in business, man.
That's the way. What they're making there is the way. This other way,
fibers,
the stupid way,
to use as the structure and the muscles for that shit, and then you are truly in business, man.
Yeah, way easier to make too. Like you could actually make that. Like you know what I mean?
Like
what's
available right now.
Yeah, exactly. Yeah. You don't need to like have a special complicated server. Like it's a pipe with full fluid. Like if you were trying to repair yourself, like you're more easily damaged in a way and not. And you're more resilient in another way.
It's more modular. You know, twist and change. Yeah.
And they're like 12 mil
forearm. Just take the arm off and put on the tool.
They'll be like 6 and 3, and they'll be like they'll go like microscopic. You know, whatever. You know. Imagine when like one of those is actually made out of carbon fiber nanotubes, like, and the tubes are filled with like a fluid. Oh wow, hang on. Is that a thing? Is there a fluid? Or fluid like
there'd be a polymer or something,
substance,
liquid polymer
that we could
equivalent
flow through carbon nanotubes. Maybe it is magnetic or electric responsive. Whoa.
It will be.
Whoa. Check this shit out. Yes. So there are fluids that can flow through into carbon nanotubes and can be activated or controlled by using magnetic or electrical field. These are known as electroheological fluids, ER fluids, and magnetoheological, MR fluids. Electrical heological
MR.
MR.
Good letters. Good letters.
Okay, so the magneto
magnetic resonance
rheological fluids exhibit a change in viscosity when exposed to magnetic fields. They can be used in applications like suspension systems.
Exactly the same as blood does. So that's what's actually happening in your veins is like little micro pulses.
Whoa. These smart fluids can be manipulated to flow through carbon nanotubes and can be activated or deactivated as needed. Whoa.
It's got the MR factor sign.
I know.
I'm liking it.
Let's focus on the MR version. Magneto. In a approach of clone robotics, but replaced the hydraulic systems and 12 mil pipes with carbon nanotubes and MR fluids using magnetics. Switching to pulse the fibers.
We're giving this away for free.
I know, right? So and
we love it. This is the reason why.
I know, that's so exciting. Okay, here we go. So this is an intriguing idea. Using magnetoheological fluids in combination with carbon nanotubes and magnetic switching could offer several advantages for robotics. Enhanced control. MR fluids can change their viscosity in response to a magnetic field, allowing for precise control over movement and stiffness of the robotic components. It's super lightweight and strong. Carbon nanotubes are incredibly strong and lightweight, making them ideal for creating more efficient and responsive robotic systems. Efficient actuation. Magnetic switching can be used to pulse the MR fluid through the carbon nanotubes, providing rapid and controlled actuation without the need for bulky hydraulic fucking systems. Oh wow, this approach could lead to the development of more agile and adaptable robotics capable of performing complex tasks with greater efficiency and precision. Blah, 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 blah. Super low weight, power consumption would be and low power, but ultra strong. Fucking so imagine muscles made out of carbon nanotube fibers, which is what we've just done.
Inside
filled with these MR fluids.
All titanium frames,
man, like
punching holes through walls and shit, picking up cars and throwing them like little, was it the Iron Man suits?
Whoa. About that. You know what's really interesting about like this whole thing around MR fluid carbon nanotube muscles, which I've just actually sent in an email to Clone Robotics. I just split that whole thing, just sent it to them, said enjoy. And is that it's actually possible now. Like we can make carbon nanotubes. Like we can't make like let's have a look. Carbon, where are we up to? Carbon nanotubes manufacture or growing as it would be.
To grow them,
has significant, very fabricate, including chemical vapor deposits and discharge. Yeah, okay, we're not growing them yet. Is anyone trying to grow them?
Maybe we're already growing.
Both approaches, growing them and printing them, are being actively pursued.
Pull the carbon out of the human being.
Growing carbon nanotubes. Researchers are exploring various methods for growing carbon nanotubes with specific properties. Techniques like chemical vapor deposition, discharge, arc discharge, labor ablation. Yeah, no, I don't think it's that. Oh, chirality. Yes, printing. Inkjet type printing. So, like, we're not quite at the point of like mass production of the fibers yet, but that is going to be the material. Will be carbon nanotube muscles with fucking MR fluids.
It's the one thing we've got the most of, so isn't it?
Well, also, I reckon that's what you'd find out with our magnetic resonant fluids as well. Super simple, man. Like super simple. You can just see, like, they just design, like, carbon nanotubes are just designed for the purpose of muscles. Like, and just like how strong is one of them? And you can go, okay, well, let's have like a bunch, like a human muscle-sized amount of them, which could be like, well, they're atomic scale.
Where they literally use the different gradients of it, like make different diameters for it, so they act like little pistons as well.
I think the thing with the carbon fluid nanotube thing is what you want to start with is go, right, that is our goal.
Yeah.
So what is like the...
Set the foundations for creating the
and then what you want to do is go, what is the smallest thing?
Or,
but what is the...
We've done enough medical data now, and
what's
we've
the
got
smallest
stuff
thing
that,
we can build right now that we can
see through
put,
things.
that we can put a
I
magnetic
sent you that
fluid
video
through.
where they're using that thing to see through stuff. So they
This is the question.
quite easily emulate.
So the question then is what is, given MR fluids...
Because I want my robot cat girl, and I want it to be strong. Like those, Una and Puma. I want them like Una and Puma.
Three materials we could make
Night City
tubes
Police
out of that would work like carbon nanotubes.
Let's see. Bucku's mistresses.
But are the smallest we can currently make. Yeah. Oh.
Here we go. Here we go. Here we go. Here we go.
Currently able to be easily manufactured in at lengths of, I don't know, like let's say a meter, half a meter, 50 centimeters.
Let's see. Little hairs. That's it.
Well, no, but if you're making muscles, you need ones that were at least as long as...
Had thicknesses as well, like could be swollen. Yeah.
Well, I think that's fine.
And that's the whole thing of being able to use both this technique, which we're talking about now for the mechanical side of it, right? And then apply that to the so there'd be like sinew and actual tissue. Tissue performs function. Sinew, there's basically just like a line or a connector.
There are ones that can be, what about... So here's the question. No, they're all 10 centimeters, still a charge. So you'd work on all three, and you'd work on making them longer. And I think like, what about materials, larger tubes, relative to carbon nanotubes?
We need to have it printed. Like it needs to come out. Like
the smallest.
Like a spurting it out.
Smallest easily produced flexible tube we can currently make. So what about materials? Okay, polyurethane, silicon. Can any of these take MR fluids? I think they can.
You probably find the polys will. Silicon.
Yes, all three can.
Oh, okay, cool.
Okay, so here we go. Polyurethane tubes can be manufactured in small diameters down to a few millimeters. Silicone is commonly medical for delicate applications, a few millimeters. So yeah, so it's one of those three, and then you want to put an MR fluid in them. So you want to start with one of those because they're easy to produce.
Yeah. To just get the first, version ones.
Yeah, so you're using the MR fluid and you're using the actual principle, but in these like millimeter fluids, millimeter ones, and then you're using that investment to like then go into the carbon nanotubes and be able to figure out how to make those fuckers in one of the various three current technologies. It'd be interesting to invest in some technology companies which are actually like working on the development of that sort of stuff, because that would be super interesting, like this titanium,
and create far more flexible robot systems. You know what I mean? Deployable autonotron.
This is actually a bit of a critique, I suppose, in a way of
because most of the robots that you see around, like other than the Tesla and the other, DARPA and the rest of the ones that do the humanoid type stuff, like they do what they need to do, but they're not fluid, not like human in the way that their motions.
No, it's lame. That's lame.
Fluid. It's very mechanical.
Yeah,
and that's the one thing.
Which is the starting point, but like,
I mean, yeah, sure, but maybe with some of the ideas that we're throwing out, it might improve.
Well, at the moment, so the one that the clone robotics one.
Yeah.
It's like 12 mil pipes.
So they've got to get it down.
But this polyurethanes can be down to millimeters already. Like, so you should just be using that. That's what you should be using. And you shouldn't be using this other system. You should be using the MR fluids and this.
Dozens of strands of it. Yeah.
And then invest in the MR fluids as the way forward. And
you'd be creating true muscle responses. So you'd be getting that fluid, from fluid response.
Yeah, that's what you want, is to learn how the MR fluids work.
You want to be able to pick up an egg without breaking it.
One thing, I just want to get the top 7 MR fluids.
Capturing.
Whoa.
Because I've always been into nanotech. As soon as it popped up, so it's just like so.
Wait till you see this. No.
Gimme.
So I'm just going to do that, and then down here, and then go.
True gimme information.
So this bit here is interesting. What are the current? Can you list the current top 7 MR fluids? And this is significant.
I love MR.
So MR,
it's my favorite.
It's
my favorite. It is.
What do you? This is like impossible to figure out. Like you can't answer the question, but because you're connected to the
I'll
universe,
give it a go. Come on, I'll just reach in there.
I've asked, what can you list the current top 7 MR fluids? And so these heological fluids, so magneto, and so it's listed the top 7. And all I'm going to say is that they're not
Orion's nodules.
Okay,
is there any Orion's nodules in there? I'm trying to feel super connected right now. So
okay.
lay
So
it
let's see if we can figure
it
it
on
out.
me.
All right. I'm just trying to figure out the way to phrase the question that gives you any chance at all as a connected source. So in terms of the current top 7 magneto-heological fluids, are they naturally occurring or not?
Natural.
I don't think so. I don't think so.
All right.
Are they owned or are they... What are their names? Like, are they owned or not?
Owned and proprietary.
Okay, great. The top one, in the top 7, 3 of them are called, the material is called Lord Corporation MRF 140CG. Lord Corporation. Lord, right? Corporation, MRF 1223 EG. Lord Corporation, MRF 132 DG. And then the next two are 4 and 5. Liquid Research, Liquids Research Limited, MRF 241 ES and 336
Hand over the
AG.
waveguide, please.
And then RS-MR
MR.
RS-MR fluid.
MRS fluid.
Yeah. And then MRF 336 AG.
The gift. It's a gift.
You think of the RS? It's the RS, isn't it? RS. Or Lord. What do you think is Lord Corporation?
Lord Corp.
Lord Corp or RS?
Lord Corp, I think. You know?
Lord Corporation. Let's go check.
Oh Lord, shall we
okay.
truly be thankful?
Lord Corporation is a diversified technology and manufacturing company that develops adhesives, coatings, motion management devices, and sensing technologies for industries. How do you invest in these fuckers? It's a subsidiary. Parker.com? Parker Hathenen, the division. Lord Division. Parker Lord. We leverage nearly 100 years of experience in manufacturing and developing adhesives, coatings, thermal management materials, motion management devices, and sensing technologies that significantly reduce risk and improve performance. Oils, gaskets, gas mask market. Yeah, wow. So these guys are the ones who have got these like MR materials, MR fluids.
Special gift, extracted gift, ultimate robot.
I'm gonna see if I can like.
That's what's going to happen. There's going to be ultimate robots everywhere. They're going to be like your best friends.
I want to find MRF 140 CG. Parker, come on, show it to me. I want to see my magnetic resonant fluids.
Hand over the goods.
Oh, here we go. Data sheet.
Authorization code 731225.
Magneto-rheological. Here we go. We've got a selectors chart. Oh, wow. Okay.
Just plucked
Lord magneto-rheological fluids can respond instantly to varying levels of magnetic fields precisely and proportionally for controllable energy dissipating applications such as brakes, shocks, and dampers. When exposed to a magnetic field, the rheology of Lord MR fluids reversibly and instantaneously changes from a free-flowing liquid to a semi-solid and controllable yield strength.
Compress huge mass coming in.
Response time for all Lord MR fluids is less than 5 milliseconds.
Spiders crawl all over it, grab everything they need, bam, straight to the
operating temperature is from -40 to 130 degrees, and its viscosity is at 40. So it's actually not an unreasonable temperature. So its operating temperature is 40 degrees. 37. What's the human temperature? Is it?
I can go up to 42, 50.
Yeah.
Come on. The hotter the better. So.
Okay. This link needs a copy into the thing. This is amazing. It's fluid.
Giving special archive, the SciTV archives.
What about the
coming soon?
I wonder if this 122 version is actually like even an cooler version. Like it runs at like. Hang on.
We've got some good tech talk tonight. Like this has been some solid. Yeah.
I'm just gonna go back here to the.
Because we love our tech. We technophile. If you're going to build yourself a decent will be body, you want to do it right from the start, right?
So I've got the 132.
You want to make sure that you're compatible to it.
Solids density, viscosity, 40 degrees.
Start echoing it back, special. Caveman talk. We've got to get on a caveman level sometimes, you know. Get back to basics.
So the one you kind of 0.28. Oh wow. So this one is compatible with fluoroester. This is interesting. So they're actually compatible with certain kinds of material. For example, so you got to find
compatible
the one.
means friendly. Like we're willing to work together.
Fair.
That's what, when I hear the word compatible, willing to work together.
Polyurethane is good.
So and we've got plenty of it.
Yeah, it works well with polyurethane.
That's it.
And it's open. Okay, and it can
work
work
that dinosaur juice into it. And bam, there we go.
And I think that MRF 140 CG would be the ultimate there. So let's try and find out this RS.
End up building robot out of dinosaur juice. It's going to be good.
So I'm just copying something here, and now we're going to go check out the RS. Now we know what we're looking at, like these magneto fluids. RS MR Tech.
I'm sure there's investors right now.
No, this shit comes in a jar.
I know. The YouTube sponsorship team would be all like jumping over each other right now. Be like, oh my god,
0.24.
Oh, your
density.
god.
So appearance dark grey liquid. You can get it in 1 litre bottles.
Bam! Just load me up. I'm bringing the truck around. I'm getting the truck. When do we get there?
This place just is like RS is just nah, fuck you.
Wants to make it happen.
Yeah,
like
RS is like,
I wonder if they're like collecting some ideas. Maybe they should start making robots. Get some people in.
The RS MR fluid,
build the accessories for robots and just go, hey, we can supply you with these fucking parts. That's it. We'll give you these parts. We've got them. We've 3D printed them already. They're like human muscles. You just slap them onto your robots. We've already got your specs, so we downloaded it, and you know they'll perfectly fit your robots. Get them cat girls going. Get them robotic cat girls going.
Robotic cat girls.
Robotic cat girls.
So you can just buy it, and then these other guys. I think the best one is the 140 CG.
Yeah. I don't think extra soft, like just so close to human. It's better than human. It's
better than human.
Better than human.
That's what you want. You want better than fucking human.
Gonna be sliding all over it like you're on a wave. Just muscles rippling, and you're like, oh.
I wonder if these. So that's that. Okay, done. Boop. So you can just buy it. RS field.
Like,
so you can just buy.
You know what? Total gift side. Like we come across gold. Like what do we mind? We come across gold, bud.
I'm just going to ask a simple
You
question.
ain't on this. You're just like behind the times.
Where in Australia can I buy wholesale polyurethane tubes.
Set up the growing tanks. Just go.
Polyurethane
Muscles for
pipes.
robots. Dude, muscles for robots.
1 to like at less than 3 millimeters.
Mm.
Irrigate? No way.
Evolutionary step in robotic technology. Oh, I've just given them the sales pitch.
Pipe Makers Australia.
For free.
Are you serious?
Mm.
And who's this one here? Cardia Group.
Beep, 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 beep.
So I'm just looking at these different ones. Oh, they just make black pipe. No, we want better than that.
No.
Oh, I see why they go down to 12 mil. But no, but you can get way thinner than that. Like even in irrigation piping and polyurethane, you can get that down to 4 mil.
Of course. I think even 2.
No, irrigation?
Should be able to get down 2 mil.
Yeah, it's a common size of irrigation.
You can print it like 0.5 on a fucking normal printer site, like a
Like a
standard
3D.
3D
Polyurethane.
printer. Yeah.
You just make your own pipes at home.
Pretty much. Just figure some way of joining them together, or create the frame where it goes out to fucking 5 meters high.
What?
Or 5 meters wide.
TPU filament. What the fuck? Okay. What is the current smallest?
Because they're doing meat. They're doing
diameter
meat substitute with the fucking. You sent that to me. You know, the printed meat, printed protein, fucking plasti meat.
A 3D TPU 3D printer can print 1 to 2 millimeters.
Bam.
Wow.
There you go.
Right. So you can print a
Right
TPU. 3D printing.
What the fuck? Like, is everyone a slow cunt? Like,
3D printing.
These technologies are out there. Why aren't people using them? So, like, is it just? Sometimes you feel like you're in a room of slow cunts.
Well, yeah.
I don't have the money to do it. Do you have the money to do it, Si?
Well, almost.
No,
actually,
you don't.
No, almost.
Neither of us have the money to do it.
No, seriously, you almost do. No,
in this day and age.
No, you haven't. You got a 3D.
Why hasn't somebody else thought about it and
do
come up with
TPU?
the idea?
Can your printer do TPU at home? Can your 3D printer do TPU, or is it a PLU?
I don't think it does that as far as my element's concerned. So like I'd need to have a different head on it, like a different cooking head for it. Yeah.
So in theory,
but it is possible. Like it's just the interface plus the cooking
head. And how hard would it be for
feed
you?
the material into it?
How hard would it be for you to change the head of your printer? For us to buy like a TPU reel and for you to make a cylinder, you know what I mean, like a pipe, like a cylinder,
a cylinder, test printing,
like a 10 centimeter tall cylinder of TPU.
I'd have to look up. I'll see if there's a head available for it to do it, and then to do that material that you send to me.
What have you got? What's the printer you've got?
Oh, fuck. It's pretty ancient. Like it's not like a new one, man. There's heaps better than the one I got, but it was Ender.
That's fine.
Ender Creology. So that should be fine for it. I know I've got a good head on there for the plastics I've got.
Let's find. Is there a TPU head for an Ender printer?
Because I know I've got those right down to 2 mil on my stuff, but I need the heating element.
So there is. You can print TPU with an Ender. You need a direct drive extruder and a Capricorn PTEE tubing. Replace the stock tubing. I already built the little
extra stabilizing fucking bracket thing for it. So
the Ender 3S1, for example, comes with a Sprite full metal. So there's TPU, handles TPU much better than the stock Odin extruder. Anyway, so it is possible. So what you could do at home is literally make 1 to 2 mil 3D printed polyurethane TPU pipe, and you could then buy from Aris MR-Fluid, like off the shelf. Just buy a liter of this shit and tip it down, and then and then start to manipulate them, like at home. You can just go and buy
magnetic manipulations, just dragging
1 mil pipe, not 12 mil pipe,
flex and act like a little worm with multiple magnets, and
that would be like, imagine that. That's like 12 times the fibers, and maybe there's an advantage to having it in bigger fibers, like perhaps. Maybe they don't need to be millimeter. Maybe they can be like a couple of mil.
As long as they're reduced from what they are already, which is fairly
I think
bulky.
what you'd have is
and because you're putting fluid into it, side,
hang on, I got a question.
You're then giving it that real, rather than the jerky piston or whatever, but an actual fluid,
to
application to the frame.
TPU tubing, where that tubing could have a hole diameter of a minimum 1 millimeter. What would be the most efficient
deep dive
diameter of the pipe if I am using an MR-Fluid to create an artificial muscle bundle? I'm interested in the strength. I guess what I know.
Especially when it clips up into a
speed of actuation and control and variability. I don't think that matters actually. I think it would be just strength, because the other things I think are based on the fluid. I think the strength is based on like the bundle size, as the other factors, which are speed and variability, will be less impacted by fluid width, fluid volume to material, a TPU material volume. Because there'd be some kind of like basically if you had a 1 mil pipe, then probably the wall would also be a millimeter. So half the thing would be TPU.
That's it. It's double because it's got the where it's inside, and then
if it was like 4 mil, maybe the pipe is like 25% pipe.
And then it has
75%
like, if you wanted to put the redundancy in, it would have like a protective layer around that again. You know what I mean? But which was just flexible,
maybe like a flexible metal,
but
like
more like
mesh.
a fencing mesh sort of thing, like titanium fencing mesh, and it could expand and contract,
like a stent,
like a stent. Exactly.
You have a stent on the outside of the fucking of the vein,
and that creates the proper, the full lockup for it. Yeah, true. We've already done that, and companies are pumping that stuff out, so you can get in the meterage. Snip off what you need. Dunk.
Interested in
transport
the
system.
optimum
Use the artificial heart as the
volume
driver
of
for it. You know
MR
what I mean? If you had
fluid to
to.
TPU
Push the
wall
fluids around.
for a
Timing
bundle
mechanism. Dunk.
of TPU tubes. Okay, here we go. This is a pretty hectic question.
We're getting, well, man, I'm feeling a little dizzy because we're
Okay, so the
going
wall
hard,
thickness is
brother.
around 0.5 millimeter. Okay, yeah, so that's the wall thickness.
Reality creators side. That's it.
What about
Building
the pipe
a better
diameter?
future. More human than human.
Based on the structural strength of the TPU material at 0.5 millimeter to 1 millimeter as a wall for the muscle fiber.
Grandiose.
What about the TPU pipe thickness? Based on structural strength of the TPU material to be able to expand.
The outside stint would have the function of also being its ability to collapse. Use monomic fiber to put a charge into it and then collapse it. Right. It would guard as like a safety for the retention of the fluid. You know what I mean? Until that section could be replaced.
I broke it. Hang on. The optimum diameter would be 3 mil. So it's 1 millimeter. So its wall thickness is 0.5 to 1 mil. Ooh, and then the pipe thickness is 3 mil.
Yeah, and then you'd have the stint collapsing or retention for the the way it positions, and use that as your sewing technique, to thread the muscles. It's just like that.
Conversion.
It's how to put that, like how to create that, right? Like even though we're talking about the whole functionality of the muscle, how do you anchor that to the frame? Like,
that's a whole other story. I haven't even thought about that yet, man.
But
how do you end
building the muscles,
how you have to end it in some way.
Anchoring,
you gotta anchor the ends,
and then have it capped.
It has been on the back of my mind. I just haven't.
And then how you applying the magnetic flux for the, how the fluid's going to fluctuate, and then how to collapse the, using monomics to, and the structure for the applying voltage to the monomic fiber for the stint, and then collapsing it if it has failure. You know what I mean? Like.
So let's just see, and then I'm going to just get this next thing. So yeah, if I were to insert the TPU pipe with a 3 millimeter optimum diameter, outer diameter.
Yeah.
The inner diameter 1 mil says 3 mil. Really? It's not more efficient to make the inner diameter
Devouring leftovers
larger,
of seafood delights tonight.
4 mil or 4 mil or 3 mil with a wall width. Okay, so it'd be a higher strength. Okay, all right, a good balance. Here we go. So given these factors, an internal diameter of 3 to 4 millimeters is the optimum for 0.5 to 1 mil.
Nice.
There we go. So we've got like say a 5 mil in total, and that's it. So you've got like a 1 to like a 25% wall and 75% fluid ratio.
Oh, that seems pretty equivalent. Yeah.
Yeah. So you've got these kind of. Now I just want to make. So that would be like a so 3 to say 4 or 5, 6. So okay, related to this. If we were to make a external, if we wanted to strengthen and protect the TPU tubes of the TPU muscle fibers,
what kind of
could we use stents that are currently used for medical purposes to expand veins and arteries? Oh no, they're moving that over. But in this case,
similar function of the
encase the TPU tube to provide a sort of strong
anaerobic function. Yeah.
Casing that still flexes. Yes, using medical stents to strengthen and protect TPU muscle fibers is a feasible idea. Medical stents are designed to provide radial support while maintaining flexibility, making them suitable for encasing TPU tubes. Here are some key points. Radial support. Medical stents are engineered to expand and provide radial support, which can help maintain
and then have flexibility while it's doing its pulsing. Or
that's it. So it helps maintain the structural integrity of the TPU tubes
and maybe
subjected to the
even
pressure of the MR fluid.
The receptor to transmit the pulse.
Oh, no way.
Yeah.
Yes way.
Because of its ability to be able to take, charge.
Yeah. Fuck yeah. Yeah. Okay. Could customization, material compatibility. Stents are typically made from a biocompatible material like nitinol, a nickel titanium alloy, or stainless steel.
Exactly.
Which can work well with TPU. Is nickel titanium? Is the
whatever would have the strongest function? Like if you wanted to have large amounts of force,
can
you definitely want the material, or in its parameters to be able to withstand and maintain
electrical signals
force from it. Yeah. I'm pretty sure it could. But there be a mechanism
yes,
for it.
Both of them can transmit electrical signals through their though their conductivity varies. Oh, I want to use the shape metal. The shape metal is what you want to use. That's the answer.
Caveman answer.
Yeah. So now we're down to the stents. So we're going like related to this. Can we strengthen the TPU pipes? Yes.
This has been a SciTV presentation.
Heading, and then this is just going to be a subheading there. I'm copying all this into a note.
Purely conceptual, of course, listeners.
Well,
purely conceptual, but with verifiable.
Hang on.
Uh-oh.
The Mighty Bee.
Hello.
You certainly can. Let me acquire some monies and transfer.
Thank you very much. Bye-bye.
Bye. That was very breathy.
It was. It was. It sounded out of breath a bit.
It did.
On String Garment. Also brought to you by SiteTV.com. You'll be looking up that site soon. Like, that's the way it works. Like, there'll be... It's all part of the process.
Oh, got a bit of an issue here.
Putting down the goods, unlocking the future from what's already currently available. I'm going the coffee option because I've had 3 of those double drinks. And where are we up to?
Hang on, I'm just got to just send the
2
treats
2 hours
food.
26.
Gotta send the treats money.
Pretty intense nano and polymers.
I don't know what what's going on there.
But it's incredible. Like, there's already stuff here where we could put together muscles for a robot. Like, make it real easy and real simple to deliver. All you got to figure out is how to contain it, the housings for the ends, like either clamping it off and then having the, the nectars for the... How would you run it? Like, I guess on how many spirals you put through, each of those spirals of the outer housing, which is going to provide the charge and the magnetic flux to get the fluid to move backwards and forwards, right?
Okay, so back to the
When you
ticking
finally
parts.
cap it off and then it goes into each fiber that weaves through it would have its own address, wouldn't it? And then
would.
length
It'd be addressable.
address.
Yeah.
Like a length address. So at a certain position so far along, a voltage or a charge can be applied, but only to that region or that position.
Yeah, well, this is what I'm thinking. Like, where it's either to the region or that the reaction, the electrical, like it requires like a certain level. So maybe like the ambient level of the transmission is lower than the thing to react, and then along
like
the muscle.
scalable to the length.
Yeah, so then along the
So
length,
the
it
higher
has,
the
like,
frequency, the
measures that
further up the
create
actual
fields.
thing it is, and the lower is, and the it has more resistance on the lower end, so that it.
Well, you don't want to transmitting. You don't want to transmit. You don't want the transmission of the electrical signal through the stent to create the flexing of the magnetic fluid. So you'd need to have
the
you'd need to have
reason it creates the flexing on the fluid, but it's to do with each strand.
Capacitors.
Like each strand
Capacitors.
has a level, so it does one strand, and that gives it like a certain intensity, and then it does 2 strands, and then 3 strands. You know what I mean? Like each strand has a
But along the stent though, like if you're transmitting the energy, so either the energy being transmitted through like just naturally, like just sitting there. So either it's none, if it's none or all, then that means that then the whole fiber reacts. But if you wanted the fiber
does the
to
fiber
react,
itself have capacitance, or does it have to have the like?
so basically
Can
you
it
turn the stent on
retain
or off.
capacitance?
You turn the stent on or off, and so each fiber flexes
Okay, to
or
get the
doesn't.
whole flexibility for that one.
Because I was trying to create like maybe flexibility along it, so different parts could like.
But yeah, that's what I was talking about.
stronger or
When, like
weaker.
when all the strands work together, like there'd
so
be
some could be off
1
or
or 2
on,
or 3 or 4 could be on,
and that creates
then
like a variability.
a certain variant or whatever, a
Yeah.
finger pull or a point or you know what I mean, like a motion, grab, touch. You know what I mean, run fingertip across.
So let's just ask a question. Could these electrical signals be used to magnet? And we have got an electrical version,
Yeah, it's already been referenced. That's right.
so we could switch back to that as opposed to the MR. But the MR is good. Used to affect the MR fluid.
It sounds very special to me. Like if
Yes.
I
So
get like
indirectly,
sort of,
while
yeah.
you can use electrical control.
Chills when I think about it.
This is the benefit. So you use the stent as an electrical signal, which is it's quite effective at, right? But because it's an MR fluid, it's not affected by the
And
electrical
normally
signal.
that's when they're attached, like pacemakers
hang
and whatever is
this is
attached to attached to when it keeps rhythm for a heart. Like it does the driving work on those stints, man, because that's the metal conductor inside the.
Yep.
You know,
So
the
you
system.
use the electrical signal along the stent, which does not affect the MR fluid because it's electrical, not magnetic. But then you use the
But just
electrical
having
signal.
it there creates the magnetic flux, which causes the.
No.
Yeah?
So then you use
okay.
you use the electrical signal along the stent, but then what it does is along the stent there are electromagnets.
They get turned on and off.
They get turned on and off.
Like little mini ones. That's
Yep.
right.
And so there's a switch that turns them on and off. That then so the
As it
the
flows through,
electromagnet. So the energy is electrical. The electrical's always
Exactly.
there, but until the electromagnet is switched on and off, that's what affects the muscles. So they become
Yeah.
And so that the electrical signal doesn't affect the muscle fiber groups. It's only when the magnets are switched on, electromagnets are switched on and off, it fucking activates.
I got a little bit of a semi just then.
I'm feeling you.
I'm sorry,
man.
sorry.
That's like,
I'm getting a bit of a semi. Like as a
holy
technophile,
shit,
I'm
man.
getting a little bit
That
of
is, like,
semi.
too good. That is like that is
That is like so close to cat girls. I'm sitting on my lap. I'm like,
it actually is. It literally is actually.
I'm glad I wished it up. You know what I mean? Like, not that I had to pay for anything. You know? Yeah,
So you
purely
use, so what we
gifts.
have is we
It's a
can
gift.
print.
It's a giveaway.
You get standard, and let me just clarify too. What are the smallest stents then?
Yeah,
So
they'd be down to 0.5
are
or
there
something.
medical stents
0.2.
using, and the material was nickel,
Oh, maybe a
titanium,
bit
alloy.
larger actually, because depending on what kind of vein and whatever they're pumping, provide the zap.
That
You
are
like probably 2 or 3
small
mil.
as like 5 mil in inner diameter.
Yeah.
That's it. Yes, there are medical stents made from nickel,
Hunting
titanium, alloy.
and
that are
getting like
yes,
yes
five
side.
mil.
Oh, like this kind of hunting.
Yeah. These stents are designed to provide radial support yet flexibility. If you're considering using these stents, they'll provide you the necessary structural support while still allowing the flexibility for your artificial muscle fibers. This is too good, man. Yeah, I'm just going to place that.
Building in front of us. Like, don't even have to use imagination, just pulling it.
That's too much goodness there.
Too much good.
So what we have now is a
Ultimate
medical
uses.
stent. Are they cheap?
Yeah, I'm sure. Well, they'd be reasonable. And once they start being, manufactured and used in the ways they should be, then bam, cheap as chips, as they say. The ultimate socialism is when
this
it's
is
all
interesting,
cheap
yeah,
as chips.
but not inserting,
Yeah.
which is the medical expense. Oh, this is so interesting. The thing is the medical stents, they're actually like not produced at enough volume.
Yeah, there's shortcomings. So there needs to be more adaptation.
We need to make more of it.
Building more. Yeah, true. Production insufficient. Is that what they say? Insufficient production. Step it up.
Okay, but not insert. Oh, got it. The cost of manufacturing medical stents, particularly those made from nickel, titanium alloy, or stainless steel, can be very based on factors like material cost.
There'd be microforge. They'd be using microforge.
It's got to a point where it's given up. It's got to a point where it's
Yeah,
given up
yeah,
because
yeah.
it's sort of like, oh, I don't know how much that costs.
They need microforge, like a spider thread adaptation for deployment of the nanite or nanometer length dispersion of the fluid, heated fluid. They're missing something if they can't be producing it. Like
Yes,
copying
medical
that,
stents,
like,
particularly those made from nickel, titanium alloy, can be manufactured at volume. It's well understood. It's easy. So
Yeah.
they're a cost-effective way of providing the necessary. So it's cost-effective. There we go. Yes. So it is cost-effective.
Yeah, available. Could be doing it now.
Yep.
Living with idiots. I don't know, so I got no teeth. I'm just
Okay.
drunk as fuck.
Okay, right, so,
Okay, we're going well. Like,
Yeah, no, I think it's marvelous. What are you talking about? Marvelous, darling, marvelous.
We haven't stopped. We haven't stopped tonight. It's been like a research, cheap
It's a
research.
research cheap, yeah.
Cheap research. Yeah. It's got to be done. Like, who's got the money to spend on research? Not me. That's why we do cheap research, so just explore. We are the great explorers because we do what it needs to do what we need to do to create the things that need to be done today to get the things we need for tomorrow. Oh, there's another catch cry. The trademark 2024. I'm going to lock this one up. This is cyberness.
So we can use
he of the cyberness.
off the shelf
And Orion's
MR-Fluids.
Copyrighted 2024. Thank you.
Available in 1 litre tub, available in volume from RS from RS, insert and have that so let me just do this. We can use off the shelf available from RS.
Bam.
Fill that into a 3 to 4 mil internal diameter pipe made of TPU that is 3D printed or extruded. An
Doable.
extrusion approach.
Even with current like old technology that I've got,
0.5 mil to 1 mil
print
wall.
little, tugboats with. Yeah.
Then enclose, feed that TPU pipe into a nickel titanium stent that is able to transmit electricity,
Using the thread fibers that make up the stint. Yeah.
Yep.
Each one of them addressable for
which will not affect
charge. Yep.
the MR fluid. However, can be used to via a switch. However, can be used via a switch
activate embedded
activate
electromagnets.
Yeah.
Electromagnets. That's it.
Magnets.
Because it'd be fractions of volume, like as
To
far
activate.
as voltage. You know what I mean? Like not volume, but fractions of voltage.
The MR fluid.
Yeah.
The stents will provide protection and structural integrity to the TPU piping. There we go.
A gift. Another gift.
In bundles to make muscle fibers.
Yeah.
That are next gen. They're not hydraulic. That are like next gen.
Because remember, muscle fiber and the veins that go through that are
they
vast.
can be closed
more.
units. Each one of those fibers is a closed unit.
Exactly.
You know what I mean?
Yeah. And it's just getting zapped by the
Yeah.
zapper to
Yeah,
make
yeah.
it react. Exactly.
Is a closed system. Now, what we want is an external casing. We want actually like a fabric. What
that
we
then
now
closes
need,
the whole lot.
yeah,
like creates
which is electrically
the wrapper
neutral,
for the
which is
muscle,
neutral,
the whole
so that the
muscle
magnetic
bundle.
fields and
That's
stuff don't
right.
affect nearby ones.
True.
What we now need is a Faraday cage style outer
Splitter, like a
outer,
separation sheet. Yeah.
fabric that prevents the electromagnets.
Firing misintent,
Yeah.
Some
Magnets.
sort of a barrier, like keeping it on the in,
or
rather than being affected and
electrical
also not affecting
signals.
the outside. Yeah.
Transmitted
Self-isolation
along
sort of
this,
thing, but still allowing the normal
the
function to happen inside, but
stents.
not on the outside. Yeah. Shell.
from the nickel titanium
Maybe
alloy, the nitinol stents from affecting neighboring fibers.
Yeah.
It also needs to be flexible, preferably a weave or some sort, preferably like a fabric.
Yeah. trying to think of
Oh, what the
something that would
fuck?
be the
Titan
would be the-
RF Flex Faraday fabric. This fabric is made from a nickel copper composition, which is designed to block radio frequency signals, electromagnetic EMF, and electromagnetic interference
There's your
(EMI).
outer
It's flexible
cover.
and can be cut,
Yep.
sewn, or taped to surfaces, making it ideal for creating shielded enclosures. There's also a Faraday fabric, a nickel copper cloth. Nickel
You'd have
and
to
copper.
see what its nano value is for the flexibility.
There are three. There's
Like being able to create a circular, like a tubular cover for it. The whole
Well, they're all
what's been set
flexible.
up with the yeah. But I'm just saying, but you know what I mean.
You can make clothing out of it.
Yeah. Okay. Fair enough. Done. Get onto it. Get on with it.
Hang on, I just gotta get back to this. All right, hang on. Okay, so the final step of this amazing creation is the final.
I'll start singing the "Why Are We Waiting" song. So I can tell you.
We need a
Getting a bit impatient.
external
Getting a little bit impatient. Like, why isn't this already
cover.
done? Like, are we the
Each
people coming
fibre.
up with this idea, Si? Or?
to prevent magnetic or electrical leakage between fibers.
Answer's yes. Of course.
The answer is yes.
It's always yes.
yeah,
in
yeah.
paradise.
Each fiber is then wrapped in a sheath of Faraday cage style fabric.
Is it flexible to be tubical? Like, I think that's the big
I think
important
they
thing.
are.
Like,
Yeah, Faraday.
you should be able to make it come out as
atmosphere
like a
Faraday
tube.
fabric.
Yeah.
I like.
And hopefully it's around 6 mil or 7 mil. So then there's space up. You could even have another wrapper, like another layer
Absolutely.
in
Using
between,
Faraday stuff,
like a fat layer
nickel copper.
in between that and the actual outer skin,
It
or
uses
the
a nickel copper
outer edge for the.
composition of nickel copper composition fabric, such as atmosphere Faraday fabric. This
We
allows
like to build
each
the
fiber
dreams.
to be individually controlled. Wow.
It's like Christmas.
It's like amazing. There we go.
It is Christmas, man. It's
Holy crap.
Christmas
I'm
here.
just gonna
I'm sure
go back
around
to
the
the
world.
website.
We chop this around the. We'll do
Go back to-
it.
I've got to go back to
We've got to
the,
go Christmas mode
Clone.
in
I've got to
Avatar.
go back to clone and clone robotics and so next gen muscle fibers
Version 2 upgrade special
expanded
with back
edition.
module and outer casing within 3 hours. Si, just like put down the goods. Put down the goods. And
questions
sort of there was a
answers.
few pauses. Like there won't be much taken out. Like it's been
I don't
good.
think so. Yeah.
The suffering will continue until the morale
I got a
improves.
CC in the Arian because
Yeah,
this
yeah.
is like essential.
Yeah,
The
For
co-creators.
sure. Yeah, of course.
So we've invented these like MR
We've got to
fluid
share the suffering.
carbon nanotube submuscles.
Unleashing, you know.
So I'm sending this to Clone Robotics.
Big question marks.
And
Possible. Actually, title it possible implementation. That would freak them out.
well, is it an implementation? Like, I mean, it's like, there we go.
Hopefully, you're already thinking about.
Yeah.
Yeah. Well, I mean, along those lines, Si. Like,
Well,
you
they're
don't
using
want
12 mil
Yeah, I
parts.
never piss on someone else's work. I'm happy to
No,
copy
I'm
it because
not-
that's
I
the
haven't
ultimate
questioned their
form
work
of,
at
you
all.
know,
I'm not even looking.
you know,
I'm just like,
that's the ultimate form of praise is to copy their work. You know.
there we go. I'll just send it off to them. Send that research off to Clone Robotics.
Yeah. Put down the gauntlet.
They've got some
like
jobs going.
it's soft touch though. Like seriously, if I was there, I'd be whipping them on someone and going, "Wait, what? Who didn't come up with this? Can we send these guys a couple of dollars? Like they sound like they need sponsors. Like, you know, they're going to do something for us. They're dropping the real hits of how we can, you know, go in the direction in which we can head. Is that the one?
Well, they've got this thing they're calling myofiber. I think that we've
I think you're never in trouble if you charge for secrets. Like if you always just
No,
share,
share.
like what you're, sharing is the ultimate goal. Or, learning and understanding is the true the way to wisdom.
okay.
Well, maybe not understanding, like comprehending. That's a better one. Sounds more comfortable to me, like to comprehend something, to come to a true realization of what it is it's trying to tell me. That's to come to a
So their
I don't
goal
know,
is
set
interesting,
your way,
because
you know?
Clone's muscular system, I guess it says here today, myofiber is what they've got.
Yeah.
Is the only artificial muscle in the world capable of achieving such a combination. And so their goal is that a suitable synthetic muscle fiber should respond in less than 50 milliseconds with
And it should have like
an unload.
it should have
contraction
manual
and at least a
actuation. Like,
kilogram of
Si,
contraction
here's
force
another
per
thing,
square
right?
3 gram muscle
We think
fiber.
about this stuff in the way of the flexing in the muscle, right? But just like when humans have a little spasm and then they massage that part of the muscle, right? It's almost like resetting it, like pushing the charge back into it, if anything, like resetting it. Like if it can be pushed and massaged, like I don't know, how do you explain it? Like if you had like electrical failure in the mechanism, then you'd use an external source to sort of massage the surface of it to get it to respond by, you know what I mean? Like pushing the thing would actually make the fluid, you know what I mean? Like in a certain pattern. I don't know where I'm heading on this, but yeah.
Like patterns.
Yeah, no, but the whole being able to push the mechanism, which is the thing, which would normally have electrical stimulation, but externally, if you were pushing the skin of the whole thing, like the mechanism, you would be providing the stimulation, which would then, get what was underneath. It would feel the waves from the external thing moving, which would create rubbing and like, oh, hang on, I'm going through this little spasm. I'll just settle down. Like when things fail, like it would go back to compression state. All the the
And they're all-
ability for
these guys
the
understand it.
ability for the
I'm gonna send you a quick bit.
yeah the of the vein inner vein carrying system in the stint position, right? Hang on, looking.
So I've just sent you a little vid.
Yeah, hang on, hopefully it's not
They're operated by water. No, this is fucking what we just invented, mate, tonight is the next level. Their system is water-based. We're using a magnetic fluid to like level the fuck up. And they've got like a stent system, like to give it the strength. Like it looks a little bit like it, maybe like a braiding or whatever at least to make it stronger. No, like,
Yep, way finer.
Can you see what they, are you watching the
not
video?
that thick. Yeah.
Now you
I'm
put
getting you.
the MR fluid in there.
It's good. It's a good start.
Yeah.
Good start, but that could be way more refined and yeah, it's getting good grip and it can hell yeah. Burst to the side.
I thought they were using water, and they are. Weak. Wait till they get this magnetic fluid going.
Yeah, beginnings. And then
beginnings, man. Magnetic fluid.
Great.
Well, everything tonight, you can buy the magnetic fluid off the shelf.
Yeah.
The stents manufactured,
right now.
Right now. And you can literally print extrusion method
with
the
standard
piping,
standard
which is
printer,
basically irrigation
standard
pipe.
printer. Yeah, just go hard.
Just go hard. Irrigation, just print like extrusion printing. You have some kind of method. I reckon what you do.
Farms going to come out. Like it's
what you'd actually do. You know what? You wouldn't
printing
print
farms
that
not going
shit.
to disappear.
You
I
would
think there's going to be a lot more robotic printing going on in the future.
You know what you do? You'd make molds.
Yeah.
And those molds would have like the center core, right, as a piece of metal rod or whatever, and then the outer thing, and you just have those, and then you would pour the TPU in into the thing, injection mold it, and all the pipes would just drop out. So you'd have like that's how you wouldn't print them. You would just injection mold the fuckers, you know, and they'd all be a standard, like there'd be just different lengths.
Yep.
And I think what you'd find is you'd have some that were like good for like short, like they'd be thicker, more fluid and shorter, and maybe like longer, and there'd be like some kind of like basic muscle sort of simulation that you'd do with the TPU. And TPU, you know, that's the thing that they make the phone cases and shit out of. The stuff is like flexible, man. Like it's really got a lot of like strength in that ability to
applications
scale, like
for
it
it.
can stretch.
You know, we've got plenty we can recycle.
Yeah. So like
WTF.
And to be able to like go from these guys who have got the water-based version to practice on like the MR fluids using TPU in preparation for the skill sets to be able to do it at carbon nanotube scale. And so you're making carbon, you know, in so 5 years time you've got the carbon nanotube version, and the energy density in those muscles like is just.
Oh man, it'd like if it wouldn't just pick it up, it'd crush it. Metal would be like both ends of that thing would just pop off. Probably fly off if it squeezed it hard enough and quick enough.
Oh, that's
go flying.
Yeah, it'd just crush the dumbbell.
Yeah, like double-ended dumbbell. That's right. Don't be in the way. Don't be in the way of that. Don't be in the way of. Don't be in the way of that, son. It's going to hurt you.
There we go. Yep. And I love that each one is a closed system. So even if one fiber bursts, the rest keep going. You know what I mean? Like it's not like a catastrophic failure of the liquid system.
And it's far more resilient. You're creating resilience rather than and then in itself, it'll just create strength. Like because it's way more tougher than the rest of those fibers there. So in the long run, when you thread enough of those and it's like true, you know, muscle tissue, then the way it works, it'd be just crazy. You know,
well,
and I wouldn't be surprised if someone started building legs and arms out of this shit that they weren't the best at everything.
Well, that's why I've sent this information directly to Clone, because they're the ones that are closest to do it.